Another function that has been developed recently these years is the satellite launcher. So what has been used is you take the arm, being the ISS RMS or the GEM RMS, and you mount a little adapter on the arm. And this adapter has a preloaded satellite with spring-loaded. So you mount this satellite inside the station it's done by the crew. So the crew is mounting this on a little platform with spring-loaded. Then you put it outside using the airlock. The arm is grabbing this little launching platform, put it in the right orientation, and then you trigger the springs to get loose, and then you eject practically this little satellite into space, like on this picture, where you see a small satellite being pushed outside to space in a 45-degree angle. So that's something which is a minor activity for the robotic arm, but it does exist, and some universities and small companies are relying on this functionality to put satellites into space. So in that case, you can put your satellites up inside the station or outside the station on a temporary parking, and then the arm is picking up and launching it in the right place. Another activity that happens very seldom, but it happened, and what we did with this arm is we had to relocate a station module, and it happened already, and it's still happening. So for instance, you can take a space station module, close the two hatches, removing the space station module and put it at another place for different reasons. Here this happened back in 2015, where the main storage module of the station, so the PMM, has to be moved from a nadir location to a forward location to free up some space for extension of visiting vehicle berthing ports. And the PMM relocation was done with the SSRMS, supervised by crew, but most of the maneuver were all done by ground. So the ground was actually flying the arm and was removing the launch lock and the attachment locks. The crew was there to prepare all this and to reconnect the module at the end. All that done from the inside, no spacewalk necessary. So here you see a picture of the module being detached to the station and being relocated at another place. So that's a minor activity. All right, as a third part of this lecture, I think which is important to know is if you want to fly an experiment or whatever outside of the station, even if you want to temporarily store something on the station, so let's say you want to bring new battery to the station, but you want to temporarily put them somewhere, you don't have all the possibilities. You cannot just take Velcro or glue them anywhere you want to have, because there are some constraints. Some other payloads and some other experiments are already running. We have antennas, we have cameras that we don't block the view. There are some thermal constraints, there are some EVA, so spacewalk constraints that we don't want to block a translation path from the crew whenever they go out. So payload location outside of the station will be a driver for you if you want to design an experiment where you want to go. And also a second part of this, part 3, is if you approach with a visiting vehicle, where do you dock on the station? You cannot go anywhere. Again, there are specific places where you need to go, and then to approach these places, it has of course a certain trajectory, so it has a big impact also on the planning of the mission. So the first is, if you want to have an external payload running outside of the station, what you need to do is to be located in one of these places. So we have different places along the truss, so which is the ELC1, ELC2, ELC3, ELC4, and you see that you have also some of the possible locations which are on the Columbus external platform, and also, as we have seen some minutes ago, that you can also put a lot of, there are more space on the side of the Japanese modules of the GEM external facility EF. This is the main places where you can be located as an external payload. There are also from few locations to be on the SM, on the service module on the Russian side. But for that, if you want to go there as a scientist to put your experiment, it means that you will have a Russian spacewalk to take your experiment out of the pressurized cabin and put it outside. No robotic means can install your payload on the Russian side yet. So all the other ones that you see on the top of the screen are possible to be installed without any spacewalk necessary. All right, so if you want to launch your payload, you need to find a spacecraft to launch your payload. Now you know your destination, you pick one of the locations, and then you need to put your payloads in different parts, in one single part or 2 parts or 3 parts, and then you attach it to the right place. It's mounted in the launch vehicle. Here it's an example of the back of SpaceX Dragon, the unpressurized part, so the cylindrical part. So you see here this experiment was cut in 2 pieces, which was a RapidScat, which was a system that was scanning the streams in the atmosphere as well as the rain. And on the right hand side was the antenna. On the other side was the Montic platform, and it has to go all on Columbus external platform. That's one of the landing location or one of the installation location. So this is once your payload is ready, it's integrated in, for instance, here in Cap Canaveral, and it's on the back of SpaceX. SpaceX launched to space. Dragon is captured by the crew, is berthed on the below the station, and then you take the robotic arm with SPDM, and so SSRMS and SPDM, and you go inside the trunk and you extract your payload out of the trunk, which is not an easy task, as you can see. You have a lot of complicated and tricky movement to do, and you don't have tons of good views to see what you are doing. I mean, the arm has cameras, yes, SPDM has also some cameras, but for instance here, this is what the ground operator will do, and all what I'm saying, getting your payload out of the trunk is a ground operation. So the ground is doing it. So this is, for instance, what they see. So they see a part of the trunk with the arm on the right, and they try to extract the payload. So they extract the payload, then you see at this picture, it's kind of mess because this is the final position or where the payload is going, and here you don't even know what is the arm and what is the payload. So actually the payload is going on the bottom side and the arm is on the upper side of the picture. This was how you put your payloads up and how is it mounted. And I said you were supposed to pick a vehicle, and the visiting vehicles, some of them will need the arm to dock, some of them will not need the arm to dock. This is something that I already mentioned. So here on this picture you have all the visiting vehicles that are known to the station. So we have on the left hand side 2 Russian spacecraft plus the European spacecraft. At the bottom we have the shuttle, and then on the upper right we have 3 other vehicles. So the names are, we have Soyuz, Progress and ATV on the left hand side, and then on the right we have Cygnus, Dragon, HTV, and at the bottom the Space Shuttle. ATV and the Space Shuttle do not fly anymore. Everything else is still flying. Okay, I exclude MPLM because MPLM was a specific case. So you see that I have done 3 categories so that you understand how critical the arm is. On the left, the 3 vehicles are docking by themselves. So Soyuz, Progress, they don't need the arm, they just dock by themselves to the station. So ATV is not flying again. On the right hand side, Cygnus, Dragon and HTV, they required the arm to dock, to berth. So that's why I have written here manual berthing, and you need the arm to install them and to extract the cargo out of them. A special case was at the time of the shuttle. So the shuttle doesn't fly anymore, but the shuttle was bringing this MPLM, which was the pressurized module, just up and down to transfer cargo. So yes, the space shuttle was docking by itself to the station. It was a manual docking, so the crew was really flying it. But then once the shuttle has docked, you still needed the arm to take this MPLM out of the cargo bay of the shuttle and put it to the station for like something 2 weeks, and after the 2 weeks of the space shuttle mission is finished, you take it back again, you put it in the trunk, you close the trunk of the shuttle and you fly back to Earth. So you see that in the cargo vehicles that are flying right now, if you exclude Soyuz, Progress is the only one remaining, and you see how small it is. All the other one, the other three, Cygnus, Dragon and HTV, they need the arm to be berthed and to be grappled and berthed to the station. So that's critical. All right, where are these visiting vehicles going? Visiting vehicles in terms of the one berthing, I will not explain Progress because I'm speaking about the one that use robotic aspect. So you can dock either in the front of the station, on the nadir side, so on the bottom, so it's the CBM, common berthing mechanism. So you can attach one visiting vehicle there, or you can attach it at another place. But the problem is, until recently, until 2015, it was only this one, the CBM Node 2 nadir, where you can attach a visiting vehicle. So what they did is they had to move a space station module, as I explained earlier before. They had to move the PMM, so the pressurized module, from the original location to the side, like this, so that it freed up a new berthing port. So the CBM Node 1 nadir was freed, so that at least we have a redundancy, so we can have two visiting vehicles at the same time, and this is critical to station supply. So we already use this Node 1 nadir berthing location since it has been freed by the relocation of the PMM.